Okay, let's start. I must say that the webinar is being recorded. I will go through the whole set of slides without answering questions, and then after the presentation, we will open a space for questions, answers, and all the type of discussion. It's now 3 minutes over 10 a.m., so let's start. Good morning, everybody. Welcome to this FIWARE Wednesday webinar, which deals with robotics aspects. And in particular, we are going to talk today about FIWARE and micro-ROS. The title is Enabling Robotic Systems on Microcontrollers using NGSI. My name is Francisco Melendez, and I'm a technical expert and evangelist at the FIWARE Foundation. What are we going to see today? The agenda will cover first some introductory slides about the micro-ROS framework. Then we will go through some explanation on the synergies between context information management and robotics applications. And then the idea is to go through the structure of FIWARE ready and powered by FIWARE micro-ROS architecture. In particular, in these architectures, the SOSS-FIWARE component plays a key role because it is the agent that connects the micro-ROS ecosystem with the FIWARE ecosystem. So we will cover this component with more detail. And then I will present a very basic demo of work in progress we are doing in order to showcase this integration. Well, let's talk a bit about the micro-ROS framework. For those that are not familiar with the ROS ecosystem, ROS is the standard de facto open framework for robotics development. At first, the initial version of ROS was limited, let's say, to research and prototype robotics development. But then the recent version of ROS, ROS 2, has improved the platform to avoid or remove these limitations. And now environments like multi-robot deployments or industrial setting can run ROS 2 without the problems of the original platform. What micro-ROS is now targeting is the solution of the remaining problem, and it's the fact that ROS or ROS 2 ready robotic environments require microprocessors, require rich computing environments that often results in too expensive applications or prevent the deployment of robotics application in some context where we are limited in resources like computation, autonomy, etc. We will refer to these environments as extremely resource constrained environments. And what micro-ROS is doing is just going through the ROS architecture, solving every type of integration and enabling the traditional ROS APIs on microcontrollers. Then relying on the DDS middleware, in particular the ones developed by eProsima, fast DDS, and micro-XRCE DDS, the integration between the microcontroller environment and the ROS 2 ready environment becomes seamless through the standard ROS 2 interfaces. Here I present, for those interested in more technical aspects, the micro-ROS architecture. As you can see at the bottom, we have two environments, the microcontroller environment and the microprocessor environment. At the microcontroller level, we have the micro XRC DDS middleware, and in particular, the nodes running micro-ROS here all share XRC DDS data cloud, where the micro-ROS API allows the data exchange across different micro-ROS nodes. And on the left side, you can see the ROS2 agent. The ROS2 agent has the role of bridging the XRC DDS data cloud to the standard DDS data cloud of the ROS2 environment. Here in this slide, I am providing you with some of the more interesting links to resources regarding micro-ROS. First, I am providing you with the micro-ROS site, micro-ROS.github.io. And over there, you can find everything you need regarding micro-ROS, an overview of the framework of the project, the main concepts, tutorials, demos, and access to the blog posts. I also attached here a link to a previous Wednesday webinar in which every technical aspect related to micro-ROS, to fast DDS, and to micro XRC DDS are explained. And I'm providing you here the link to the YouTube video of this previous webinar. I'm also providing you with a link to an interesting part of the documentation, which is the eProsima integration service. This is the core component upon which the SOSS-FIWARE component is being built. Also, I invite you to join to the embedded working group conversations if you are interested in further discussion on these topics. In order to join the embedded working group, you just need to go to the micro-ROS GitHub site, micro-ROS.github.io site, and register into the Slack, and you will be able to follow the evolution of the working group. We have explained in the previous webinar, we covered the main problem that micro-ROS is solving in bridging microcontrollers and microprocessors using the ROS API and tools. But today we are going to augment this explanation to cover the aspects that are more linked to the FIWARE ecosystem and standardized context data management. And in particular, we are going to talk about how this micro-ROS powered robotics can interact with the context data infrastructure that is typically running in a network of software components that are aimed at deploying advanced features for smart robotic applications. The key domains that we are now targeting include agile manufacturing, warehouse automation, and some scenarios in healthcare and agri-food robotic applications. And some of the features that these applications require from the network of software components are listed here for providing persistence and online information access, or some features for advanced planning, scheduling that can be linked to AI concepts, or any other kind of applications that in the end aim at doing the robotic application more efficient and more powerful. What FIWARE does in this direction is to contribute NGSI, which through the NGSI specification provide us with ability and skills to develop harmonized data models and the standard APIs to communicate robotic, let's say the cyber physical components of the robotic infrastructure with the digital platform. We are not only as FIWARE NGSI providing you with specifications for these data models and the standard APIs, but also with technology. You can visit the FIWARE catalog, check all the components that are already available to be run directly interpretable through the NGSI API. Here I provide you with a more detailed view of the FIWARE catalog. As you see, the catalog is structured into 5 main chapters. Interface to IoT, robotics, and third-party systems is the chapter that is subject of the focus today, in particular for the SOSS-FIWARE agent. But you can see that a lot of features are available through the existing components. We are not limited to this in FIWARE, not only providing technology. We have also started with TM Forum, an initiative for the agile development and standardization of data models for this type of applications. I invite you to visit smartdatamodels.org and to put in and to contact us for every single data model you are interested in develop, or if you want to explore what is going on there. But let's put together the different pieces that we have seen so far. Let's consider the following example. We have the objective of automating some warehouse operations. We have an AMI, an autonomous mobile robot that is empowered by ROS2, and we decide to sensorize our floor stacking area with some proximity sensors or smart sensing devices that can be significantly reduced in cost, or its autonomy can be significantly increased by running the micro-ROS architecture in microcontroller and not using larger processor units. So this is the part that micro-ROS is solving. We will have micro-ROS nodes running on the smart sensing devices, and then using the micro-XRC DDS cloud, we can communicate with the agent that runs on the ROS2 ecosystem. At this point, tech providers, system integrators, automation engineers, robotics engineers are dealing with the problems that are linked to the cyber-physical systems of the environment. But what happens when we want to reach a more ambitious deployment? For instance, we want the warehouse manager to access data online to monitor the progress of the operations in the warehouse, or we want an operator to just control or monitor the status of some ongoing operations. What happens here is that in order to materialize this scenario, a concept, let's say today, a smart digital platform emerged here, and what it is expected from the smart digital platform is some kind of magic that solves everything, links every component, enables the interoperability between all the components to satisfy the requirements of the application scenario. The meaning of magic in this scenario is something like this. The digital platform is intended to connect every asset, to provide transparency and visibility to every digital device in order to be able to monitor the performance or condition of every asset in the deployment through semantic interoperability, or at least structured interoperability. It is expected to break the information silos between the different digital assets, and in the end, as the platform becomes smarter and smarter, it should reveal insights for efficiency, allows us to predict the future accurately, or speed up how the smart application is adapted, reconfigured, etc. In the end, what we are aiming to is to minimize cost while maintaining or even improving the current quality of the services delivered. But unfortunately, what is the common situation for digital platforms is that these platforms are built upon a complex network of heterogeneous software components that often rely on ad hoc data models and very tailored interfaces in order to enable the performance that we need. This translates into an excessive increase in the cost of every development with long development cycles and too many parties involved in the development of this platform. In FIWARE, what we are dealing with is precisely with the standardization and homogenization of these components. First of all, the Orion Context Broker is the core component in every FIWARE, every powered by FIWARE architecture. And this broker enables the NGSI API to allow the data exchange between the existing digital platform components using the harmonized open data models we are working on. And then some components that are aimed at interfacing with the cyber physical components in the shop floor or in the where the robots are deployed. In this case, I'm highlighting here the role of the SOSS-FIWARE component. But as I mentioned before, there is a rich catalog offering this type of services ready to use and encapsulated in software components. And here I'm presented some of them. The agents are not limited to SOSS-FIWARE. We have also agents for OPC-UA, which is the standard de facto for manufacturing, and a rich collection of IoT agents for many IoT protocols. But more than that, we offer ready-to-use capabilities as, for instance, I'm highlighting here some of the most interesting for robotic applications. The Perseo component offers a rule-based decision automation framework, and for instance, Quantum Leap can be used for time series management. And this slide aims also to capture that in the end, you are not forced to use everything in FIWARE or to build everything in a standardized way. You can use your legacy system. For instance, I'm showcasing here the enterprise resource planning system or the manufacturing execution system, or very specific platform for application automation. And in the end, what we are doing is just implementing part of this magic I was referring to before. We are not solving a problem that is almost unsolvable nowadays, but we are easing and accelerating how this platform can be developed by providing the standard components, APIs, and data models that accelerate the development of this glue between all the parts in the smart application deployment. What I'm going to present now is an ongoing work. We are preparing a demonstrator of the integration between FIWARE and micro-ROS, and we are focused on the SOSS-FIWARE component for that. What this slides capture is the future tutorial about micro-ROS and FIWARE will cover, and our aim is to combine these three applications. We have already a tutorial that deals with the persisting and querying time series data, and I'm providing you here with the link. Then we have another application that is very well known within the ROS community. It's the getting started application for the ROS2 navigation stack. And then in the micro-ROS website, you can access to this application, your first micro-ROS application on Linux. And we have selected this because it allows us to develop and to implement a whole proof of concept without requiring any specific hardware. You can go through the micro-ROS github.io site, and you can find over there all the supported motherboards and some further guidance on how to use it's a real-time operating system that is compliant with the micro-ROS framework. In the demo we are going to show now, we are going to focus only on one part of this demo, and in particular we have created a fictional environment in which a technology provider provides a, let's say, plug-and-play ready smart battery device that can be plugged into the Turtlebot 3. And it is going just to rely on the standard ROS messages to feed the rest of the ROS2 architecture with the status of the battery. This is what the A circle covers using the micro-XRC DDS data cloud. Then in the point B, we are at the DDS ROS2 data cloud level. And here we are on the ROS2, within the ROS2 ecosystem. And what we will cover with SOSS-FIWARE is how this south port that connects to the DDS data cloud can translate the necessary information into NGSI and put it available in the Orion Context Broker. So let me change the screen into the demo. Well, what I'm showing to you here is a splitted console. Here I have run an Orion Context Broker that is ready to receive NGSI context data. And in this part, we will be running the SOSS-FIWARE component. On the bottom, at the bottom on the left, we have the micro-ROS agent, which is the bridge between the micro-ROS ecosystem and the ROS2 ecosystem. And then we have built a micro-ROS application which simulates the behavior of the smart battery device. So I will run first for instance, the micro-ROS agent. It is now running at port 8888. And now I'm going to run the micro-ROS node. As you can see, I have implemented just a silly behavior that is simulating the consumption of the battery. And now we are going to run the SOSS-FIWARE component. Now we have this architecture entirely running. We have at the bottom on the right the micro-ROS client, on the left the micro-ROS agent, on the upper part on the right the SOSS-FIWARE component, and on the upper part on the left the Orion Context Broker. And now I'm going to use the Postman client to show how this is being translated into the NGSI world. Let me show to you first. Okay, we can make a simple query to list all the entities that currently exist in the Context Broker, but let's focus on a very specific one. This one. What we have done here is to provide the equivalent to the battery state message in ROS in NGSI. As you can see, the micro-ROS architecture is publishing this NGSI data model in the Context Broker. We have here the information of the battery entity, and in particular, we can refine this query not to retrieve the whole entity, but the attribute, one of the attributes we are interested in. For instance, I have prepared here a query to receive the percentage. We can query the context broker, and if you pay attention to this number, you see that the whole integration is working, and we receive our updated battery percentage. This proves the integration, and now what I'm going to show to you is how we have set up the SOSS-FIWARE component to communicate the micro-ROS ecosystem with the Orion context broker. This is the typical configuration file for the SOSS-FIWARE component. Let's pay attention first to the systems structure. We have two systems, ROS2 and FIWARE. We have provided the necessary information to set up the FIWARE bridge. And then we have the concept of routes. These routes aim at representing that we are communicating in two directions, from the FIWARE world to the ROS2 world, and from the ROS2 world to FIWARE. And then we have prepared here the mapping between the topics and the ROS topic and the NGSI world. And what we are saying here is that we are publishing in the ROS world sensor message battery state, and that this message maps into the FIWARE world using the type smart battery ROS. Here we rely on the standard interface description language to model this mapping, and the SOSS-FIWARE does everything for us and publishes everything we need. And this is the part of the SOSS-FIWARE configuration, and here I'm just showcasing the code that we have developed in order to implement the micro-ROS application. So you can see that the micro-ROS application is running with only a few lines of codes. I have prepared some of the parameters, and here is the behavior in which we are simulating that the battery is being consumed, let's say automatically recharged when it runs out. This is what I wanted to present basically today, and I will prepare a step-by-step tutorial that will cover all the parts that I have presented here in the... Let me recover the presentation. All these parts I have presented here. As a summary, I provide you with this final slide in which I recap all the necessary links to receive, to get the relevant information. You have the link to the micro-ROS site, to the FIWARE catalog of enablers, the link to the previous webinar on the use of DDS middleware, this interesting link to the eProsima integration service, and the specific links to the SOSS-FIWARE component and the generic SOSS component. You can also contact me at francisco.melendez@fiware.org for any further discussion you consider. I can point you to the people you need or to discuss with you the issues you're facing. So please count on me for this. And thank you very much for joining the webinar. I hope to meet you again in a future session. Bye-bye.